This is a video introducing Venn diagrams. I just want to start with an example. A Venn diagram is a method for representing information, usually data, not always. Okay, so here we have U. U stands for the universal set. That means that U contains all the elements that we're interested in. Another example of this would be the alphabet would be another example of a universal set. And then we split those sets or partition those sets into subsets. And we've got A, multiples of 3, and B, multiples of 4. An analogy with the alphabet would be vowels and consonants, for example. Okay, so let's go through the list. And we're going to represent this on a Venn diagram. This is a Venn diagram here. And once we've done that, we'll investigate the various regions. So we've got 1, which is neither a multiple of 3 or a multiple of 4. We've got 2, which is neither a multiple of 3 or multiple of 4. We've got 3, which is definitely a multiple of 3. We've got 4, which is definitely a multiple of 4. We've got 5, which is neither. We've got 6, which is definitely a multiple of 3. We've got 7, which is neither. We've got 8, which is definitely a multiple of 4. We've got 9, which is definitely a multiple of 3. We've got 10, which is neither. We've got 11, which is neither. Then we've got 12. Now 12 is an interesting one because it's a multiple of 3 and also a multiple of 4. I want you to pause the video and see if you can calculate where we put the 12. Hopefully you've done that now. So the 12 goes in the middle. So this middle here represents A and B. The outside is not A or B. This represents A. This represents B. Okay, so let's have a look at the various regions of the Venn diagram. Okay, so the different regions of the Venn diagram are quite important because we're often asked questions about numbers in particular regions or probabilities in particular regions. So I want you to pause the video and see if you can describe each region here. Okay, so let's have a go at doing an explanation. This represents A and B, but not both. We use a special word for that. That's called mutually exclusive. An example would be summer and winter. It's either summer or winter. Another example would be Monday or Tuesday. Okay, so here's another example, and this represents A and B. You can study history elective and geography elective at the same time. You can wear two colours. For instance, I'm wearing a white shirt and black trousers at the same time. Okay, the next one just represents A. The next Venn diagram just represents B. This is not A, sometimes written as A prime. This is not B, sometimes written as B prime. I just want to have a look at a closer look at these Venn diagrams here. This represents A or B. You don't need to know this, but this is how it's written in maths. This is A and B. And this is written like this. So this is called a union. It means or. This is called an intersection. Okay, now see if you can pause the video and see if you can work out what region this is. So hopefully you've done that now. So this is not A or B. And this can be written as A union B not. Okay, so now that we are familiar with the regions, you might want to copy them down into your book. So pause the video and copy these down because they're quite important in calculating probabilities. Okay, so let's have a look at the next question. So pause the video and please have a go at doing this. Okay, hopefully you've done that now. So U, if you remember, is the universal set, curly brackets for set. That is everything A, B, C, D, E, F, and G. B is just B, which is D and E. Remember that the intersection is both A and B, but it is still in B. C is the set of elements in A but not in B. Set of elements in A but not in B are A, B, and C. D is the set of elements in U that are not in B. So that is going to be everything that's not in B. That's going to be A, B, C, F, and G. Then the last one finally is going to be the set of elements in both A and B. A and B is just going to be D. Okay, I'm going to do another one. I'm going to say F. What about the set of elements in A or B? See if you can calculate that. Pause the video and see if you can calculate. Okay, in A or B, there's going to be everything in here. Remember, A or B was this region. So that is going to be A, B, C, D, and E. So let's have a look at a probability question. So this is quite common. I want you to pause the video and have a very close look at those numbers. Okay, so hopefully you've done that now. So the total here is 28. And let's add up the data we're given. 15 plus 21 plus 3. If we add those up, we arrive at an answer which is greater than 28. We arrive at 39. So if we subtract 28 from 39, we realize that we've counted 11 twice. So let's see if you can work out what that means in terms of a Venn diagram. Okay, so let's music and art. Let's do 11. Okay, now we've counted that 11 as an extra one, so we need to subtract 11 from both music and visual arts. So let's do that then. 15 minus 11 gives 4. 21 minus 11 gives 10. And 3 study neither. Okay, so that 3 goes outside. Now, before we answer that question, let's do 3 questions. I want you to work out the probability of music, the probability of only music, and the probability of not music. The not art. Probability of not music. Get the right color here. Okay. Okay, that is not music. So pause the video and see if you can have a go at doing this. Okay, so the probability of music, we're going to be in this region here. So 11 plus 4 is 15 over 28. Okay, only music is just going to be this region here, which is going to be 4 over 28, which is going to be 1 over 7. 4 sevens are 28. Okay, the probability of not music, that is everything apart from music. So everything apart from music is going to be 13 over 28. So I can shade that region in now. So not M is going to be this region, which is 10 plus 3, which is 13. Okay, so let's get rid of those. Oops. Okay, so let's go back to our original question. The original question was, what is the probability that 2 students study both music? Now, these are going to be successive events which are independent of each other. So we multiply. So the probability of music, let's rub these out so it doesn't confuse us. Probability of music, and remember that the intersection in the middle is also music. The 11 people who do music and art also study music. So we have got a total of 15. Out of 28. So that's the probability of choosing the first person who studies music. So if you've chosen one person, the size of the class reduces by 1. So we now have a class size of 27. And we have 14 students to choose from. So use your calculators. We've got 15 over 28 times 14 over 27, which gives 5 over 18. Okay, so let's have a look at another question. Okay, so the total here is 32. Let's add them up. We've got 18 study history, 24 study geography, and 2 study neither. So if we add those up, we get a total of 44. And if you notice, 44 is greater than our total before, so we do the same thing. 44 minus 32 is equal to 12. And I hope you can see that we've counted 12 in both of history and geography. Okay, so we've got history and we've got geography, and we've got, let's use green this time, 12 in the middle. So history is 18 minus 12, which equals 6. And then we've got 24 minus 12, which is 12. And then we've got 2 study neither. Okay, so let's have a go at some questions. Let's do 4 questions this time. 1, 2, 3, and 4. And let's rub this out so we get some workspace. Okay, so I would like you to calculate, let's use a nice thick one, the probability of history or geography. If you remember, we wrote that as probability of H union G. Then I want you to calculate the probability of history and geography. The alternative notation, which you're not forced to use, is intersection G. Then the probability of history, then the probability of not history. That means not history. Okay, now before we do that, I just want to discuss 3 and 4. The probability of history plus the probability of not history must be equal to 1. Must be equal to 1. The probability of winning the lottery given you by a ticket plus the probability of not winning the lottery must be 1. You either win or lose. The probability of getting ahead plus the probability of not getting ahead must be equal to 1. Okay, so pause the video and see if you can do these. Okay, so the probability of H or G is you're going to add up all these things. We're in this region here. So 12 plus 12 is 24, so we've got 30 over 32. And you can simplify that to 15 over 16. Okay, the intersection, we've got 12 over 32. And that simplifies to 3 over 8. Do that. Okay, we've got the probability of history. Probability of history is going to be 18 over 32. So 18 over 32 simplifies to 9 over 16. Then you've got the probability of not history. So that is going to be 14 over 32. Let's double check that. Not history is going to be 14 over 32, which is 7 over 16. Now I hope you can see that 9 over 16 plus 7 over 16 equals 1. We would have been in big trouble if that didn't equal 1. Okay, so let's have a look at these questions. So pause the video and see if you can do the 3 questions. Okay, so pause the video. Just had a little computer malfunction. I'm amazed. My computer just shut off. I'm amazed it's still running. Okay, so have a go at doing the 3 questions there. And then I'll go over the solutions. Okay, so let's have a look at those solutions. So we've got I, which is the probability a randomly chosen student studies both history and geography. So that is history and geography, which is 12 over 32. And 12 over 32 simplifies to 3/8. Okay, a randomly chosen student studies geography but not history. So geography but not history. So if you remember those regions, so that is just going to be this region. Geography but not history, just this region here. So that's just going to be 12 over 32, which is 3 over 8. Let me see if that's right. Student studies geography but not history. Yeah, they're both 3 over 8. Okay, and then finally the last one, 2 randomly chosen students both study history. So that is probability of history. Okay, so history is 18. 18 out of a total of 32. Now we've already chosen one person from the class. So that's now going to be 31. We've already chosen one person who studies history. So let's work that out. We've got 18 over 32 times 17 over 31. Which gives 153 over 512. Let me just double check that. No, it doesn't. I have done 32 times 32 in the denominator. Okay, 496. That's good. Okay, so I hope this helps. Venn diagrams can be difficult, but if you think really carefully about the regions and where the numbers go, they become a little bit easier to get some inference from, and that means to draw conclusions from the Venn diagrams. Okay, bye.